everyone. Myself Prayag Patel, working as assistant professor in IT ICT department of LG Institute of Engineering and Technology. Now, in today's video lecture, I discuss about the next unit, unit number 7, backtracking and branch and bound technique. Now, in today's lecture, consider the backtracking method. Here, consider the outline for the today's video lecture. First, consider the introduction of backtracking. Next one, consider as a 8 queen problem using the backtracking, and third, consider the knapsack problem using the backtracking method. Now, first consider what is the backtracking. Backtracking can be defined as a general algorithm or general algorithmic technique that consider searching every possible combination in order to solve an optimization problem. So here consider the backtracking method is a recursive technique or recursive method. In generate, here consider the generate one state space tree for the all the possible solution for the backtracking method. So consider the state space tree for the all the possible solutions. It traverses the state space tree in the depth first search order, means according to DFS you traverse in this state space tree. So in a backtracking we attempt solving a sub problem, and if we don't reach the desired solution, then undo whatever we do for the solving that sub problems and try solving the another sub problem. Means if you find the solution in one path, if solution is not available, then you can backtrack in your previous node and find the another way for solving your problem or find the solution. All the solutions require a set of constraints divided into two categories: explicit constraint and implicit constraint. Here consider the two type of constraint or condition are there, explicit and implicit. Here explicit constraint means, for example, consider the n queen problem. Then n queen problem, consider the solution as a value from 1 to 8 only for 8 queen problem. So consider the 1 to 8 solution only is considered as an explicit constraint. Now implicit constraint means you can put the queen in, not put in the queen in same row or same column or diagonal, is considered as an implicit constraint. Now consider the problem of the n queen. So here consider the n queen problem, means you can consider as an n queen problem like for n cross n chess box, you want to put the n queen in this chess box. So here consider the n queen is the problem of placing the n queen on a n cross n chess box so that no two queens attack each other. So here consider the when any queen attack to another queen. Here consider the two queen of the same row, same column or the same diagonal can attack to each other. So here consider put your n queen according to this rule, not put any queen in same row, not put any queen in same column, or not put any queen in the diagonal of any another queen. Here consider the k promising solution. A solution is called the k promising if it arranges the k queens such a way that they cannot threat each other. Means here consider the k queen problem or k promising solution means you can put the k queen according to your condition which defined in previously. So here consider the first case. Here consider one queen in 2 cross 2 chess box. Here consider this chess box as a 2 cross 2 chess box. In 2 cross 2 chess box you put the one queen, then consider the one promising solution. Now consider the in 2 cross 2 chess box, if we put the first queen in first position at location 1 1, then first row consider as a row, first column consider as a column, and last block 2 block consider as a diagonal. So another queen is not possible in 2 cross 2 chess box. So here consider the, if we put the two queen in same first column, then this is not considered as a solution. So that's why we can say that this is a zero promising solution. Now consider the queen in a diagonal, then also consider as a no solution for the two queen problem. So here consider this is a zero promising solution. And if we not put any queen in particular chess box, then consider also as a zero promising solution. So in 2 cross 2 queen or 2 cross 2 chess box, you want to put the two queen but not possible, so we can say that Now consider the 4 queen problem. What is the 4 queen problem? N queen problem means in n cross n chess box you want to put n queen. Here consider the 4 queen problem means in 4 cross 4 chess box you want to put the 4 queen according to your rule, not put in the same row, not put in the same column, or not put in the any diagonal. So here consider value as a first position at first row. Here consider the row as a 1, 2, 3, 4 because 4 cross 4 chess box. So row consider from 1 to 4, also column consider from 1 to 4. Now here consider Q at the first position. So consider the one solution or one queen is possible. So consider the one promising. Now want to find the another row. So here consider the second row. For the second row, consider the queen for which position or at which location you want to put this queen. For example, if we put the queen at first location of the second row, for the second row consider the first position. So this position consider as a same column. So not put queen here. Now consider the next location. Means consider the row number 2 and column number 2. Here this location also consider as a diagonal for the first queen. So these two queen attack each other. So not possible this location 2 2. Now consider the second row and third column. So here consider at third column no any column are same or no diagonal are same. So we can say that third position is proper. So here consider the location 2 3 is possible. Now consider the for third row. Consider first location is not possible because here same column. Now consider the second column. In second column consider the diagonal of the your previous queen. So here this location is not possible. Now consider the next location. If we put at third location, then consider as a same column for the your previous queen. So not possible. Now consider the fourth column. In third row fourth column, here we consider this location as a last queen. But here also consider this queen at diagonal of your previous queen. So here consider not possible for this location 3 4. So here we can say that only two queen are there. In fourth row you also put one queen, but here not possible for putting the 4 queen according to this sequence. So consider this is a two promising solution. Now consider the another way. If we start the putting queen at location 3 in row number 1. So here in row number 1, column number 3, one queen are there. Now consider the next location. For the row number 2, consider the first column. So here queen is possible. This location consider not a diagonal or not same row or not same column. So possible here put the queen at location 2 1. Now after the row number 2, consider the row number 3 because in any row you can put only one queen. So here for the row number 3, location 1 or column number 1 is not possible because here already one queen are there in first column. Now consider the column number 2. In column number 2, if we put the queen in column number 2, then this queen consider as a diagonal of previous queen. So this is not possible. Now if we put the queen in third column, then also consider the same column for the your previous queen. So not possible here. Now consider the fourth column of the third row. So this location consider as a proper location because here no any row or no same column or no same diagonal. So consider this location as a final location for the row number 3. Now in row number 4 you put the one queen. So at first location here not possible because in first column already one queen are there. So same column is here. Now consider the next. In next location consider the location or column number 2. In column number 2 here possible solution are there because in column number 2 no any previous queen are there. So we can put queen here. This is considered as a no same column, no same row and no same diagonal. So final solution of the 4 queen problem is a 3 1 4 2. Here solution consider as a column number. So here consider in first row column 3, in second row column 1, in third row column 4 and in fourth row column 2. So solution as a 3 1 4 2. So this is your solution. So above 4 queen promising solution can be written as 3, 1, 4, 2. Also you can write this solution in another way, means reverse order of your solution. So here we can say that another solution is 2, 4, 1, 3. So for 2, 4, 1, 3, consider this last figure for how we can arrange the queen in the 4 cross 4 chess box. So here consider the in first row column number 2, second row column number 4, in third row column number 1, and in fourth row column number 3. Here consider the 4 promising solution of 2, 4, 1, 3. Now consider the n queen problem. Then one queen problem is considered or not. Here consider the for one queen problem means 1 cross 1 chess box are there, and in this chess box you want to put one queen. Then consider as a solution is possible, and how many number of solution is possible. So here we can say that only one solution is possible. For the 2 queen problem, no any solution is possible. For the 3 queen problem, no any solution is possible. So consider 0. Now in 4 queen problem means 4 cross 4 chess box are there, and how many possible solution for the queen. We previously find the 4 queen solution and there are 2 solutions. So here consider the for the 4 queen problem 2 solution are there. Now what is the 5 queen problem? 5 queen problem means in 5 cross 5 chess box you want to put the 5 queen. Then how many number of possible solution are there? In previous case in 4 queen 2 solution are possible. In 5 queen problem 10 solution are possible. Now in 6 queen 4 solution, in 7 queen 40 solution, in 8 queen 92 solution, in 9 queen 352 solution, and in 10 queen 724 solution are possible. So here consider this is as a n queen problem. Now consider this 4 cross 4 chess box for the 4 queen problem. Now understand the same row, same column and diagonal criteria here. So here first we put the queen at location 2, 3. Then row number 2 white shaded consider as your row, and third column white shaded consider as your column. So in this row or in this column no any another queen will be arranged. So here consider this is a same row and same column. To identify the position that cannot be choose so that the queen does not attack. So here consider this row as a first consider a row number. So in row number 2, 1, 2, 2 and 2, 4 3 locations are occupied, because in these 3 locations if we put the queen then consider as a same row queen, so attack each other. So here consider the same column as a 1, 3, 3, 3 and 4, 3. Now consider the diagonal. Here consider the blue shaded line as a diagonal. So here consider the diagonal as a 1, 4, 3, 2 and 4, 1. So here consider this line as a diagonal. White line consider as a diagonal, and another diagonal as a 1, 2 and 3, 4. So the diagonal position which are under the attack are denoted by this figure. Now consider the n queen state space tree. For the backtracking problem, you can represent your problem or solution in a state space tree. So here consider the state space tree means all the solution or all the possible solution of your problem. So here consider the 4 queen problem, and for the 4 queen problem if you want to design or draw the state space tree, then initially consider the one node as a root node. Now from this root node consider the 4 possible way are there. Now what is the in this figure what is the your node or what is the, your edges? Here in edges we write the number 1, 2, 3, 4. Means in first row if you want to put the queen at first position then possible. If you want to put queen in second position means second column also possible, third column possible and fourth column possible. So in this tree level consider as a your row and different edges consider as your column. So in first node root node consider the level number 1. So at level number 1 means consider the in row number 1 you have a 4 possibility. You put the queen at first position means in first column, then consider the queen at second position means second column, in third column and in fourth column. Now consider only first possibility. If we put the queen at first column in this 4 cross 4 chessbox. Then what is the another possibility for row number 2? Because here this node consider as a level number 2, means consider as a row number 2. So in row number 2, how many possibilities are there? We already put the one queen in column number 1 in our previous case. So here consider the column number as a 2, 3 and 4. Only here consider the column number, not consider the diagonal. So that's why we can say that in second row we can put the queen at location 2 or 3 or 4. 3 possibilities are there. Now out of these 3, consider any one option. So here consider the first option. If we put first queen in first column, second queen in second column of the row 2. Now in the level 3, consider the row number 3. In row number 3, how many possibilities are there? Here already we put the queen in column 1, then column 2. Now 2 option or 2 path is possible. One is 3 and second is 4. So if we put the queen in third position of the third row, means third row and third column. So consider for the next row, here consider the row as a row number 4. In row number 4, only one possible solution is in column number 4. If in previous case we put the 1, 2, 4, then consider last as a 3. So here one solution as a column 1, column 2, column 3, column 4. Another solution as a column 1, 2, 4 and 3. Now consider the your next case. Here consider the DFS sequence. So here consider if we select the first queen in first column, then third column, then 2 possible solutions are there, column 2 and 4. So if we first put 2, then 4. If we first put 4, then consider next as a 2. In last case, consider 1 to 4, then 4 to 2, then 2 to 3. Another case 1, 4, 3, 2. So here consider this is a possible solution. In n queen problem or in backtracking technique, we consider the each and every possibilities. If here consider the first possibility according to depth first search, then consider from first 1, then 2, then 3, then 4. If this is not our solution, then backtracking to the your previous node or parent node. From the parent node, if any path is possible, then consider this path. If any path is not possible, then consider previous parent node. And according to this process, you can move according to depth first search and find your solution. Now consider the second option. If we put the first queen in first column, then this is your solution. But if we put the first queen at column number 2, then here consider the column number 2, 3. So second option consider as a first. If you put the queen in second column, then next option is next queen at column 1, 3 or 4. After the 1, consider the 3 or 4, means we can say the second tree as a like this. Now for the third number of column, consider as a, if we first put the queen in third column, then next option consider as a 1, 2, 4 like this. So this tree consider as a 4 queen state space tree. Now consider the path of your solution. Here in 4 queen problem, we have a 2 solution. First solution is a consider as a 2, 4, 1, 3. So here red shaded line consider as your solution. First put the queen in column 2, then column 4, then column 1, then column 3. Now consider the another solution is a 3, 1, 4, 2. So here consider second path as a red shaded line. Now consider the next problem of today's video lecture. So consider the knapsack problem. Here knapsack problem using backtracking algorithm or backtracking technique. So here consider the what is the knapsack problem. We already discussed the knapsack problem in our previous video lecture or previous chapter. Here in previous chapter we consider the 2 type of knapsack problem. First one is a fractional knapsack problem and second one is a 0-1 knapsack problem. In fractional knapsack problem there are many objects available, but out of this all object you can divide the any object and consider the half portion or fractional portion of your object is considered as a fractional knapsack problem. Now in 0-1 knapsack problem you consider or select the whole object, otherwise leave it. Is called the 0-1 knapsack problem. But in fractional knapsack and 0-1 knapsack problem we consider problem like, for example, here consider the 5 objects are there. Here consider the weight of each and every object are given and profit of each and every object are given. For example, consider the first object, weight equal to 12 kg and profit equal to 4. So here consider only one object of 12 kg. Here consider the only one object of 2 kg, only one object of 1 kg, one object of 4 kg, like this. So here total 5 objects are there. 5 objects are only one time, no more than one option is possible. Means we can say that only single object is available for each type. 5 type of object and 5 type of object only one. Now consider in this problem using backtracking method, you consider the many objects are possible. Means for the 12 kg object, you have a many object of 12 kg. Then consider the 2 kg of object, second object as a 2 kg. Then many 2 kg objects are available like this. We are given a certain number of object and a knapsack. Here consider the, instead of supposing that we have n object available, we shall suppose that we have n type of objects. Means here consider the 1, 2, 3, 4, 5 type of objects are available, and that n adequate number of objects of each type are available. Means sufficient number of objects are available for each type. If you want to select the 5 object of 2 kg, then it is possible. So consider this type of problem for backtracking algorithm. Our aim is to fill the knapsack in a way that maximize the value of the included object. So here consider the, if we select the 2 object of same kg, then profit is maximum, then you can select this object. We may take a object or leave behind, but we may not take the fractional of object. So here consider the selection of object as a whole object, not fractional part of any object is possible. So consider this problem. Now understand knapsack problem using one example by backtracking technique. Now consider the example as a, we have a given object as a small w equal to 2, 3, 4, 5. What is the small w? Small w means weight of the each and every object. Means first object weight equal to 2, second object weight equal to 3, third object weight equal to 4, and fourth object weight equal to 5. Now consider the next as a v. V equal to 3, 5, 6, 10. What is the v? V means value or profit. So here corresponding value of each object consider as a 3, 5, 6 and 10. Now consider the third factor as a capital W. Capital W means consider as a capacity of knapsack, and here capacity of knapsack given as a 8. So here consider your knapsack or bag capacity equal to 8. Now here consider the situation or initial node, because in any problem using the backtracking algorithm, you represent your solution in a state space tree. So here represent the state space tree. Now in state space tree, each and every node represent what? Here consider the first node as a root node. In root node consider the two sections. First part, then column, then second part. So here in first part and second part, initially consider the solution is empty. So consider the total profit equal to 0. So here left of the semicolon are weight of selected object. Here consider the no any object initially selected. So blank portion for the left part of your node. In each and every node there are two parts. Left part consider as a weight of your selected object, and right part consider the right part of the semicolon is considered as a total profit of your selected object. So here consider like this. So here consider initial node as a no object selected, so blank part in a weight and profit equal to 0. Now select one by one option. Here consider the all the possible ways. So here we can say that initially if we select the first object as a 2 kg object, means select the first object of 2 kg, then weight of the selected object equal to 2 and profit of the selected object consider as a 3, because value of the first object equal to 3 according to our data. So this is considered as your next node. Now after that, after selecting the one object of 2 kg, how many possibilities are there? Here consider the next possibility as a, if we select the second object of 2 kg, means 2 times we select the object number 1, weight equal to 2 and profit equal to 3. So here consider weight as a 2, 2 means addition of these two consider as a 4. Now check. This total of your weight is less than or equal to your capacity of knapsack. So here total is 2 plus 2 equal to 4 and capacity of knapsack equal to 8. So here condition is satisfied. So consider these two objects and total profit equal to, if we select the first object 2 times, then profit equal to 3 plus 3 equal to 6. Now consider the second option from this tree. So here 2, 3 first root node for this tree. Now if we select the one object of 2 kg and select the another object of 3 kg, then total weight equal to 2 plus 3 equal to 5. Here consider less than 8. Yes, so possible this solution. Now consider the profit for the second case 2, 3 means we select the first and second object, then profit equal to 3 plus 5 equal to 8. Now consider the another option. First object is 2 because already consider your parent node as a 2 means already we select the one object of 2, then consider the another object as 4. So here 2 4 case is there. So for the 2 4 we select the 2 and 4, then profit equal to 3 plus 6 equal to 9. Now consider the another way or possible way are there. Here consider already one object of 2 is there. Now consider the another object as a 5 kg. So here consider the selected object as a 2 and 5. So total of 2 and 5 consider as a 7 which is less than 8. So possible case are there. So here consider for 2 and 5 total profit equal to consider as a 13. 3 plus 10 equal to 13. Now 2 and 3 case all the possibilities are there. Now consider the first node 2 and expand this node 2. Now in node 2 any other possible solution are there. If we select the first object 2 times, then next case we consider the first object 3 times means we select the 2 kg object 3 times 2 2 2. So weight equal to 6. So possible. Then consider the profit as a first object profit equal to 3. So 3 plus 3 plus 3 equal to 9. Now consider the another option from the 2 2. So after the selecting of 2 object, we select the next object as a 3. Then consider the 2 object of weight 2 and 1 object of weight 3. So weight total weight equal to 4 plus 3 equal to 7. So less than 8. Yes, then possible this solution. Now profit equal to 3 plus 3 6 plus 5 11. So here consider this is your next solution. Now consider the another option after the selecting 2 2. Here we can simply say that first 2 part as a 2 2, then next as a 2, next as a 3 and next as a 4. Simply we can say like this. So here 2 2 4 means addition of this 3 element as a 8. So your capacity of knapsack equal to 8 and total weight equal to 8, then consider this solution is possible. So here consider the total profit as a 3 plus 3 plus 6 equal to 12. Now here from the 2 2 consider the next option as a 2 2 5. This option is possible. Here if we consider the 2 2 5 option, then total equal to 2 plus 2 plus 5 equal to 9. So here total 9 is greater than our capacity of knapsack 8. So we can say that this solution is not possible. So here consider another solution. Now consider the another solution as a after the 2 3 we can consider the next node as a 2 3 3 because already here we considered 2 3 one part, but if we consider 2 2 3 then 2 2 3 is already available in our previous case, so no need considering the repeated elements. So here consider the 2 3, then consider the next position from 3 4 5 like this. So after the 2 3 we put the 3, then put the 4, then put the 5. Now here consider 2 3 3 case. In 2 3 3 consider the total weight equal to 2 plus 3 plus 3 equal to 8. So possible this solution because weight equal to 8. Now consider the total profit and total profit equal to 13. So consider this is a solution. Now here consider the another solution is possible after the 2 3. 2 3 3 is possible, but 2 3 4 means weight is greater than 8. 2 3 5 means weight is greater than 8. So not possible. In 2, 3 another solution are not possible. In 2, 4 also consider the another solution is possible. 2, 4 next solution consider as a 2, 4, 4. This solution is not possible. In 2, 5 also consider the 2, 5, 5. So this solution is also not possible. So consider the first case 2, 2, 2 and expand this node. So after the 2, 2, 2, next possible way is 2, 2, 2. After the 2, 2, 2, you can consider the value 2, then 3, then 4, then 5. But here consider the first as a 4 times we select the object 1. Means we select the 2 kg object 4 times. So consider the total weight equal to 8 and consider the total profit equal to 3 plus 3 plus 3 plus 3 equal to 4, 12. So here consider this is your solution 2, 2, 2, 2. Now 2, 2, 2, 3 solution is not possible because addition of this 4 component is greater than 8. So in all the cases here no any path is possible. Now consider your parent node, then parent node up to the root node. Now from the root node 0. First we select the first option only, means we consider the, if we select the first object weight 2 is first selected, then consider another solution or another way as a, if we select the first object as a 3 kg object, then what is your profit? Profit equal to 5. Now after that consider the another way for the 3, means 3, 3, 3, 4 and 3, 5. Now for 3, 3 consider the profit equal to 10. For the 3, 4 consider the profit equal to, here consider total of these 2 means 11 and profit for 3, 5 consider as a 15. Now after the 3, 3 consider the another way as a 3, 3, 3. So total of 3 times 3 kg weight object equal to 9. So solution is not possible. In 3, 4 also consider the next as a 3, 4, 4. Not possible. In 3, 5 also consider the 3, 5, 5. Is not possible because total weight consider as a 8. Now consider the another way. Initially we first select the object of the 4 kg. So profit equal to 6. Now in 4 case consider the another option or another subtree as a 4, 4. We select the 2 time object number 3 and weight equal to 4. So 4 plus 4 equal to 8. Solution is possible. Then total profit equal to 12. Now consider the next as a 4, 5 is possible? No. Now consider the last possible way is, first if we select the first object as a object number 4 and weight equal to 5. So total profit equal to 10. So this is a final tree or state space tree for the knapsack problem. So in this case we move the in your state space tree according to DFS sequence. So consider or now apply the depth first search. Then here consider the path like this. So here consider red shaded line is your path. So this is your first path. In first path we find the one solution. So store this solution if optimal solution is found. So initially we consider the 12 as a optimal because all the remaining path is not expanded. So here consider 10 as the initial solution. After that we consider the each and every solution or best solution or optimal solution. So next solution as a 11. So best solution as a 12. So remain 12 in your final solution. Now consider the next option as a 12. So 12 is your solution. Now next option consider as a 13. So 13 is your best solution till now. Now according to this way you can find the solution according to depth first search algorithm. Then your best solution, here in knapsack problem, what is the best solution? Best solution means you can consider the maximum profit. After selecting the any number of object, you get the maximum profit is considered as your optimal solution or best solution. So in this figure consider the 15 as a maximum solution. So here consider this path red shaded line, consider as your optimal solution 15. So how we can find this optimal solution? So consider this path for that. So here path is, first we select the object number 3 kg weighted object, then we select the 5 kg weighted object. So two objects are selected, one object is 3 kg and second object is 5 kg. So total of these two consider as 8 and total profit equal to selected two object profit equal to 15. So here consider this solution as your optimal solution or final solution for the knapsack problem. Thank you for watching this video.